The journey is going to be about 700 miles in distance, taking about 3 months. In the earlier phases, the temperatures are about -50 degrees, so it's nearly 5 times colder than a domestic deep freeze. We have been training for the last 12 months, both in terms of technical skills and in developing the equipment. So we've been up in the Arctic on 3 occasions for about 2 weeks at a time, most recently on Baffin Island, a little village called Broughton, where we've been putting everything through the ultimate stress test, really giving it a really horrifically hard time, all this equipment. Much of the time we're operating not just in daylight or twilight, but actually starlight. And so we've been doing some training in how to negotiate these chaotic jumbles of ice, where the ice crashes together, forming these chaotic jumbles. How can we navigate our way? So we're trying different sorts of lighting systems, torch systems. One of the technological developments we've had is a specially commissioned radar. It's an ice-penetrating radar that sends a pulse of energy through the snow and the ice layer and gives an incredibly detailed cross-profile every 10 centimetres along the 700-mile journey. We have this giant sort of mother of all manual drills, about 5 meters long, that will enable us to drill through the ice up to 10 times a day and take sort of tape measured, it's a super accurate measurements of the thickness. We think we can do this comprehensive detailed survey. That's what it's all about. We're going for no other reason other than to gather data, but it is going to be the ultimate challenge for us.
Basically, what this expedition helps with is that they're providing a snapshot of the most recent ice conditions, ice thickness in the winter of 2009. The data might show that the ice is getting thinner than expected, and if that's the case, this will be basically confirming many people's expectations that we're on the accelerating negative trend in terms of melt of Arctic sea ice. As the saying goes, you can only see a tip of an iceberg. It's important to understand how much ice is actually submerged in the water, eventually leading to understanding the thickness of the ice, not only the two-dimensional aerial coverage of the ice. According to our study, it's very likely that if this current trend of ice decline based on the last decade or so continues or accelerates, the ice might be almost gone in summer, sometime between 2010 and 2016.